On the evening of November 9, 2025, satellite imagery captured a scene that would command the attention of meteorological offices across the Pacific. Typhoon Fong Wong, its eye tightening into a well-defined structure, was bearing down on the northern Philippines with sustained winds reaching 185 kilometers per hour. Gusts screamed past 230 kilometers per hour. This wasn't just another tropical cyclone in a region that sees roughly 20 storms each year. This was a super typhoon arriving less than a week after Typhoon Kalmaegi had killed at least 224 people across the same islands. The Philippines was still counting its dead when Fong Wong made landfall in Aurora Province at 9:10 p.m. local time, its 1,800-kilometer-wide rain band covering nearly two-thirds of the entire archipelago. What unfolded in the days that followed would demonstrate a troubling reality documented by climate scientists. In an era of rising ocean temperatures, even storms that weaken can unleash catastrophic power. And the science behind Fong Wong's intensity reveals exactly why researchers studying tropical cyclones consider the future trajectory so concerning. The destruction began before the eye ever reached land. In Catanduanes province, flash floods swept through villages as rivers swelled beyond recognition within hours. A woman drowned when torrential rain turned narrow streets into rapids. In Catbalogan City, debris from collapsing structures killed another resident. But these were just the opening casualties. As Fong Wong carved its path across northern Luzon through the night, the storm's true power became devastatingly clear. More than 1.4 million people had evacuated to shelters or relatives' homes, heeding warnings from the Philippine Atmospheric, Geophysical, and Astronomical Services Administration. The scale of this preventive evacuation reflected hard lessons learned from previous disasters. Entire provinces lost power. In the Bicol region, darkness descended as electrical infrastructure failed under the onslaught. Communication networks struggled to maintain service as cell towers lost power or suffered structural damage from the winds. When dawn broke on November 10th, rescue teams confronted a landscape transformed by water and wind. Flooded villages stretched for kilometers. Landslides had buried roads connecting mountain communities, isolating entire townships from emergency services. At least 132 northern villages reported severe flooding, with some residents trapped on rooftops as water levels rose with terrifying speed. In areas where the storm surge combined with river flooding, the water rose so quickly that families had minutes, not hours, to reach higher ground. Rescue helicopters launched as soon as conditions permitted, but low visibility and high winds made aerial operations treacherous during the height of the storm. By the time Fong Wong emerged into the South China Sea, the death toll had climbed to at least 10, with some reports suggesting 27 fatalities. More than 240,000 people remained in evacuation centers, unable to return to damaged or destroyed homes. Philippine President Ferdinand Marcos Jr. had declared a state of emergency even before landfall, recognizing that the nation was facing a catastrophic convergence. 2 super typhoons within 6 days, testing the limits of disaster response capabilities. Fong Wong didn't appear out of nowhere. The storm began forming as a tropical depression over the western Pacific in early November, drawing energy from ocean waters that had been absorbing heat for months. Sea surface temperatures in the region hovered well above the 26 degrees Celsius threshold that fuels tropical cyclone formation. But it wasn't just warmth at the surface. Ocean heat content, which measures thermal energy stored in the upper ocean layers, had reached levels that scientists note would have been exceptional just decades ago. The South China Sea in particular functions as a reservoir of storm fuel. Research published in 2025 shows that the proportion of Category 4 and 5 tropical cyclones in the western North Pacific has been increasing since 1979, growing by approximately 5% per decade. The mechanism is straightforward physics. Warmer water means more evaporation, more moisture in the atmosphere, more latent heat released during condensation, and more energy available to intensify the storm's winds. Fong Wong tapped into this energy with frightening efficiency. The storm underwent rapid intensification on November 8th and 9th, its maximum sustained winds jumping from tropical storm strength to super typhoon intensity in less than 48 hours. This rapid intensification, defined as wind speed increases of at least 56 kilometers per hour within 24 hours, has become increasingly common. Climate attribution studies have documented this trend repeatedly. When Typhoon Regesa struck in September 2025, researchers at Climameter found that similar storms were now approximately 1 degree Celsius warmer, up to 10% wetter, and slightly windier compared to the pre-industrial climate. The pattern holds across multiple storms. Human-induced warming of ocean temperatures is loading the dice toward more intense tropical cyclones. Taiwan's Central Weather Administration began tracking Fong Wong with growing concern as the storm crossed Luzon. The island nation knows typhoons intimately. 3 to 4 make landfall or pass close enough to cause damage in an average year. But Taiwan's geography turns even weakening storms into potential disasters. The island rises steeply from sea level to peaks exceeding 3,000 meters within just a few dozen kilometers. When moisture-laden air from a typhoon hits these mountains, it's forced upward, cooling rapidly and unleashing torrential rainfall. The result? Some of the most extreme precipitation events on Earth. Typhoon Morakot in 2009 dropped 2,777 millimeters of rain in just 4 days, burying the village of Shaolin under a massive landslide that killed approximately 500 people. That disaster fundamentally changed how Taiwan approaches typhoon preparedness, leading to massive investments in early warning systems, improved evacuation protocols, and enhanced monitoring of potential landslide zones. The eastern counties of Yilan and Hualien are particularly vulnerable, their rugged terrain prone to landslides, their narrow valleys perfect funnels for floodwater. These counties sit directly in the path of most typhoons approaching from the Pacific, meaning they repeatedly absorb the initial impact of storms before the central mountain range weakens the systems. Even before Fong Wong approached, Taiwan was on edge. Just 2 months earlier, in September, at least 19 people had died in Hualien when a barrier lake, formed by landslide debris damming a mountain stream, overflowed during another typhoon. 60 million tons of water and debris had cascaded into Mingli village in minutes. Now, as Fong Wong churned toward Taiwan, that same barrier lake remained under close observation. Engineers had been monitoring its water levels continuously, but removing the debris dam would have required months of careful work in unstable terrain. If heavy rain filled it again, the outcome could be catastrophic. The memory of that September disaster weighed heavily on emergency planners as they prepared for Fong Wong's arrival.
On November 10th, the Central Weather Administration issued a sea warning at 5:30 p.m. Fong Wong was approximately 490 kilometers south-southwest of Taiwan's southernmost point, moving west-northwest at 13 kilometers per hour, with maximum sustained winds of 137 kilometers per hour and gusts reaching 173 kilometers per hour. By morning on November 11th, authorities issued a land warning. Schools and government offices closed across multiple counties. Ferry services between Taiwan's outlying islands and the mainland shut down. More than 3,300 people were evacuated from high-risk areas, with Hualien County accounting for the largest number. The storm was weakening, downgraded from typhoon to tropical storm status as it approached. But meteorologists emphasized a critical point that many people misunderstand. A tropical storm can still be deadly. Fong Wong maintained a 220-kilometer radius, and it was moving slowly, around 11 to 12 kilometers per hour. Slow-moving storms are often the most dangerous because they dump extraordinary amounts of rain over the same area for extended periods. The forecast was ominous. Extremely heavy to torrential rainfall expected in mountainous areas of Greater Taipei and eastern Taiwan, with the storm's rain bands combining with seasonal, northeasterly winds to create a potent convergence. The rain began in earnest on November 11th. By Tuesday evening, some communities in northern Taiwan had already received 783.5 millimeters of rainfall. That's more than 2.5 feet of water falling from the sky in less than 48 hours. Yilan County on the northeast coast bore the brunt of the deluge. Some areas recorded over 720 millimeters by midday November 11th. Rivers swelled. Creeks that were normally ankle-deep torrents became raging channels capable of moving cars and undermining buildings. Provincial Highway Number 9, a critical north-south route through eastern Taiwan, flooded near the 231-kilometer mark after the Matayan River overflowed. Highway authorities closed the road. The Taiwan Railway Corporation suspended operations on multiple branch lines. Ferry services to outlying islands already canceled remained shut down as waves reached heights of 3 to 5 meters in coastal zones. By the time Fong Wong made its closest approach on November 12th, the storm had weakened further, its center passing approximately 80 kilometers west of Taiwan's southern tip. Maximum sustained winds had dropped to 83 kilometers per hour, but the rain continued. Yilan County reported 76 flooding events by Wednesday morning. In Mingli Village, Hualien County, the scenario authorities had feared came to pass. A creek overflowed, inundating homes and cutting off highway access. More than 8,500 people were evacuated nationwide as the storm crawled northeast. The human toll mounted in increments. 13 people injured on November 11th. By November 12th, 51 injuries reported across multiple counties. 95 by November 13th. Yilan County accounted for 12 of those injuries, with the remainder scattered across the island. More than 1,000 homes flooded in Yilan alone, their residents wading through knee-deep water mixed with mud and debris. Power outages affected nearly 6,000 households. Water supplies failed for 370 households. Schools ahead closed remained shut as floodwaters receded slowly, leaving behind layers of silt and the wreckage of everyday life. Overturned furniture, waterlogged documents, ruined electronics. The Central Emergency Operations Center warned that the danger hadn't passed even as Fong Wong moved away. Mountainous areas in Yilan, Hualien, Taidong, Taipei, and New Taipei remained at high risk for secondary disasters. 56 red alerts for potential debris flows were issued, 35 of them in Yilan County alone. Saturated slopes could give way at any moment. Barrier lakes could overflow. The storm's immediate passage was over, but its effects would persist for days. The science behind Fong Wong's intensity, even in its weakened state, tells a story that extends far beyond one storm. Research published in 2025 examined ocean heat content and marine heat waves in the East China Sea and their relationship to typhoon intensification. The findings were sobering. From 1993 to 2022, 30 out of 91 typhoons traversing the East China Sea intensified, and high ocean heat content was associated with approximately 40% of those intensification events. The mixed layer of the ocean, that upper zone where wind and waves stir heat throughout, was generally shallow in the region, averaging less than 25 meters. But even with this relatively thin, warm layer, the thermal energy available was substantial. What matters isn't just the surface temperature, but the depth of warm water. A typhoon's winds churn the ocean, mixing cooler water from below with the warm surface layer. If warm water extends deep enough, this mixing process can't cool the surface significantly, and the storm maintains access to its energy source. Climate models project that with every 1 degree Celsius of global warming, maximum typhoon wind speeds could increase by roughly 5%. This might seem modest, but the destructive power of wind increases exponentially with speed. A storm with winds 5% stronger doesn't cause 5% more damage, it can cause 15 to 20% more damage due to the physics of wind pressure. Recent attribution studies have shown this pattern clearly. The World Weather Attribution Group found that Typhoon Kalmaegi in July 2024 saw winds intensified by about 7% due to human-caused climate change. Hurricane-strength storms in the Atlantic in 2024 were universally intensified by fossil fuel-driven ocean warming, some as much as 24 miles per hour. The mechanism involves more than just surface temperature. Warmer oceans evaporate more water vapor into the atmosphere. Water vapor is the fuel for tropical cyclones. When it condenses in the storm's core, it releases latent heat, which drives convection and intensifies winds. Warmer air also holds more moisture, approximately 7% more for every degree Celsius of temperature increase. This means heavier rainfall when storms make landfall. Attribution analysis of Typhoon Odette in the Philippines in 2021 found that anthropogenic climate change increased rainfall by about 11%. Similar increases have been documented across multiple storms in recent years.
But the changes go beyond intensity and rainfall. Typhoons are also undergoing what researchers call a poleward migration of maximum intensity. The latitude where storms reach their strongest winds has been shifting away from the equator in both hemispheres, expanding the geographic reach of these destructive systems. Rates of rapid intensification have been climbing. The forward motion of some storms has been slowing, meaning they linger longer over land, dumping more rain, causing more flooding. These trends are not uniform across all storms or all regions, and natural variability still plays a significant role in any individual cyclone. But the overall pattern is consistent with theoretical expectations from a warming climate, and it matches what climate models project for the coming decades. Scientists are increasingly confident that while the total number of tropical cyclones globally may decrease or stay roughly the same, the proportion of intense storms, Category 4 and 5 systems with the most destructive winds and heaviest rainfall, will increase. For countries like the Philippines and Taiwan, this means facing fewer but more dangerous storms. The aftermath of Fong Wong unfolded across thousands of individual stories. Families in Yilan County shoveling mud out of ground floor apartments, trying to salvage what they could. Elderly residents in Huayan's mountain townships evacuated to shelters, wondering if their homes would still be standing when they returned. Farmers surveying fields turned into lakes, crops destroyed weeks before harvest. The timing couldn't have been worse for agricultural communities. Many were preparing for important harvests when the floodwaters arrived. Emergency responders working around the clock to clear landslide debris from roads, restore power lines, pump floodwater from low-lying neighborhoods. In some areas, the damage to infrastructure was so extensive that power restoration would take days, not hours. Taiwan's disaster response systems, honed through decades of typhoon experience, mobilized efficiently. Shelters opened in 11 counties and cities, staffed by trained volunteers and equipped with emergency supplies. The National Fire Agency coordinated evacuations, prioritizing the most vulnerable populations, the elderly, families with young children, and those living in the highest risk zones. The Central Weather Administration maintained constant communication about rainfall totals and flood risks, updating forecasts every few hours as the storm's behavior became clearer. But efficiency can only mitigate so much damage when the fundamental hazard intensifies. Infrastructure designed based on historical climate data faces mounting challenges under today's rainfall totals. Drainage systems reach capacity. Flood barriers are tested. Emergency plans built around past storm patterns require constant updating. What worked for the typhoons of the 1990s and 2000s may not be adequate for the storms of the 2020s and beyond. Typhoon Fong Wong has dissipated now, absorbed into a frontal boundary near Okinawa. Its winds scattered, its rain wrung out over the Pacific. But the storm leaves behind more than flooded homes and damaged infrastructure. It leaves a warning written in rainfall totals and evacuation numbers, in the speed with which it intensified over warm ocean waters, and the persistence with which it dumped precipitation over Taiwan's mountains. This wasn't the strongest typhoon of 2025. It wasn't the deadliest. It weakened significantly before reaching Taiwan, dropping from super typhoon to tropical storm status. Yet it still injured 95 people, flooded more than 1,000 homes, displaced thousands, and paralyzed transportation across one of the most prepared nations on Earth. If a weakened tropical storm can do this, what happens when the next super typhoon maintains its intensity all the way to landfall? Based on current climate trajectories, the answer is concerning. Ocean temperatures are rising. Marine heat waves are becoming more frequent and more intense. The thermal energy available to fuel tropical cyclones is increasing year by year. Every fraction of a degree matters. Every additional joule of heat stored in the ocean's upper layers is potential fuel for the next storm. We're living through the early stages of this transformation, watching established patterns shift as the atmosphere and ocean respond to the greenhouse gases we've added. Climate models project that the typhoons of the coming decades will be wetter, stronger, and less predictable than the ones that shaped our coastal cities and disaster plans. Fong Wong fits the pattern researchers have been documenting. The Earth is changing beneath us, and the storms it generates are growing more dangerous with every passing year. If the story of Typhoon Fong Wong and our changing climate resonated with you, subscribe to stay informed about the forces reshaping our planet, because understanding these changes is the first step towards adapting to them.